In the last two lectures, we have completed no bias and forward bias condition of PN junction diode. In this lecture, we will discuss reverse bias condition. In reverse bias condition, P side of the diode is connected to the negative terminal of the battery and N side of the diode is connected to the positive terminal. If you remember the last presentation, forward bias condition, P side was connected to the positive terminal and N side was connected to the negative terminal. So in this case, in case of reverse bias condition, we are just doing the opposite of what we have done under the forward bias condition. This is the case of no bias condition because we are not applying any external voltage source across the two terminals, and let's say width of depletion layer is equal to WD under the no bias condition, and the barrier potential is equal to VB. So the barrier potential is equal to VB. We will compare reverse bias condition and no bias condition after some time. So I will write these things down. In no bias condition, width of depletion layer is equal to W subscript D, and barrier potential or built-in potential is equal to VB. Now we will move to reverse bias condition, and we will connect negative terminal of the battery to the P side and positive terminal of the battery to the N side. So let's do it quickly. This is the negative terminal of the battery and this is the positive terminal, and we will connect positive terminal to the N side. Now this is the reverse bias condition of PN junction diode, and let's say the reverse bias potential is equal to VD. And because of this, because of connecting the negative terminal to the P side and positive terminal to the N side, there's an attraction between the holes on P side and the negative terminal and the electrons on N side and the positive terminal. There is attraction between them, and because of this, holes will be drawn towards the negative terminal and electrons will be drawn towards the positive terminal. So there is uncovering of immobile ions, and if we consider the P side, negative immobile ions are uncovered because there is an attraction between the holes and negative terminal of the battery, and if we consider the N side, positive immobile ions are uncovered because there is an attraction between electrons and positive terminal. This will lead to a new depletion layer, and the depletion layer is wider if we compare it with the forward bias condition. So we have a new width for depletion layer, and let's say the new width is equal to WD reverse bias. This is the new width of depletion layer, and we also have a new barrier potential. This is the new barrier potential, and let's call it VB reverse bias, and VB reverse bias is equal to VB plus VD, where VD is the reverse bias potential that we are applying across the two terminals, and VB is the barrier potential for no bias condition. So if you increase the reverse bias potential, the barrier potential will also increase. So I will write this down. If you increase VD, the reverse bias potential, the barrier potential will also increase. And this is also true for the width of depletion layer. On increasing VD, width of depletion layer will also increase. And if we compare the width of depletion layer for all the three conditions, for reverse bias condition, for forward bias condition, and for no bias condition, then we will find width of depletion layer is maximum in reverse bias condition. Then we have no bias condition, and the width of depletion layer is minimum in case of forward bias condition. So this is important, and we will do the same thing for the barrier potential. If we compare the barrier potential for the three cases, then the barrier potential for reverse bias condition is maximum. Then we have barrier potential for no bias condition, and the barrier potential for forward bias condition is minimum. So these are the 2 points that you must remember in PN junction diodes. And now we will move to the currents due to majority charge carriers and minority charge carriers. The majority charge carrier cannot overcome the increased barrier potential. As you can see, the width of depletion layer is increasing as well as the barrier potential, and because of this, the majority charge carriers, holes on P side and electrons on N side, cannot cross the junction, and the majority carrier flow reduces to 0, and the majority carrier flow I majority is nearly equal to 0, right? And if you talk about minority charge carriers, then the number of minority carriers entering the depletion region will not change, and hence the minority carrier flow will remain same as no applied bias. So the current that exists under the reverse bias condition is called as the reverse saturation current. There is only one current under the reverse bias condition, and the current is reverse saturation current. Its direction is from right to left, IS, the reverse saturation current, and this is the only current under the reverse bias condition because I majority, the current due to majority charge carriers, is nearly equal to 0. So there is only one current, IS, in reverse bias condition, and this current is very small current in order of micro amperes. This is very small because it only depends on the minority charge carriers, and the minority charge carriers are very less in number, so the current is also very small, and it only depends on temperature. This is all for this lecture. We have completed no bias condition, forward bias condition, and reverse bias condition of PN junction diode. In the next lecture, we will see the representation of PN junction diode. We will also discuss relation between diode current and diode voltage. So see you in the next one.